Hey everyone, welcome back to the channel. So, as you may know, in my last video, we discussed how a Nobel Prize winning economist estimated that the impact of AI might be far smaller than what AI hype would have you believe. In fact, he estimated that AI might increase the total productivity by just 0.7% over the next decade. But that estimate depends entirely on one key question, and that is how exposed are different occupations to AI. And as I mentioned in my previous video, that I would do a deep dive into this. And so today, we go straight into the study behind these exposure numbers and see if you should be worried about AI taking away your job. So sit tight because this one is full of insight. So let's see how this study is structured. And for that, let's start with a quick background. So to figure out exposure to AI, what researchers did was that they started with a detailed labor data from ONET. Uh, ONET organizes the entire US labor market data into a clear hierarchy. At the top, you have occupations. Then each occupation is made up of tasks, and every task breaks down into detailed work activities or DWAs. So, for example, take a role like marketing manager. Now, one of the tasks might be use sales forecasting to ensure sales and profitability of products. And the detailed work activities under the task could be things like monitor external events impacting business, analyze market data, analyze forecasting data to improve business. Now, the way exposure is calculated is that it's calculated at the DWA level or the work activity level, and then it's aggregated upward. Simply put, if AI can help with the detailed work activity, it can impact the task, and then it can impact the occupation. Now, how is exposure calculated? So, here is the interesting part. The study calculates exposure not at the job level, but at the level of each detailed work activity. Each detailed work activity is fed into GPT using a carefully designed prompt, and the model would classify that as E0, E1, or E2. Now, what are these E0, E1, or E2? Well, these are classifications of exposure levels. So, quickly, E0 means no exposure, that is, AI can't really help with the task. AI can't weld, lift, or operate a machine, at least today. Then we have E1, which means high exposure. That is, AI can significantly accelerate the activity, like pure language or reasoning tasks, writing, summarizing, documentation, analysis, and communication. LLM alone can speed this up immediately. And then we have E2, which is even higher exposure. That is, AI, when combined with some software or tools, could automate much of the tasks. So, tasks AI helps with, when combined with software like databases, spreadsheets, CRMs, vision models, can accelerate the activity and automate it to a large extent. So, in summary, E0 is physical, E1 is language, and E2 is language plus tools. Short and simple. But here is the twist. The original study didn't publish the DWA exposure labels, and so to get to them, I had to recreate them myself. I rebuilt the full pipeline myself. I downloaded the same ONET dataset, took all the DWAs, wrote a small Python script, and using the same rubric and the same prompt from the paper, I fed each detailed work activity one by one into GPT-4. And the most interesting part was that I'm not even a technical person, but with the help of GPT, I still managed to build this entire pipeline myself. So, like I said, GPT returned the exposure category for each detailed work activity. I have left a link in the description for these exposure levels. You can go and check it out yourself. Moving on. So, what I did was then I rolled up those exposure levels to tasks and occupation level, just like the researchers did. And that is when we were able to get to some insights from the data. So what does the data really tells us? Well, the first question that we try to answer is how exposed are occupations overall? So, only 9% of the occupations have very high exposure, that is above 75% exposure. 49% of the occupations fall in medium exposure range, that is 25 to 75% exposure range, and 41% of the occupations have low exposure, that is under 25% exposure. So AI is not taking all jobs, but it is reshaping specific clusters of work based on the nature of the task. So the next question that comes to mind is, okay, so which are these occupations which are most exposed to AI? And the most exposed occupations cluster in tech, data, and analytical roles. So, for example, business intelligence analysts, data scientists, data warehousing specialists, database architects, financial and quantitative analysts, operations research analysts, training and development managers. These roles rely heavily on writing, quantitative reasoning, or structured analysis. And for these jobs, AI can accelerate the majority of the everyday tasks. The next set of insights that we wanted to derive was that, okay, these are the occupations or clusters which are more impacted, but which sectors or domains or industries would be the ones which are most impacted? To figure that one out, we had to overlay another data set to our existing data set. This data set is hierarchy of occupation groups and subgroups. What are these groups and subgroups? Well, the ONET classifies the occupations into 4 levels. Main groups, these you can relate to industries or domains. Subgroups, these are functions within a domain. Then broad titles, these are like role families. And then detailed titles or specific job types. Sounds confusing? Yes, but let's try to understand this with an example. So main group could be management occupations. A subgroup of this main group could be advertising, marketing, PR and sales managers. Within that, a broad title could be public relations and fundraising managers, and a detailed title could be PR manager. Now, looking at exposure through this lens shows us how AI will influence through various domains and sectors. And so, if you overlay this data, you get to know which domains have the most exposure. Now, some job families have overwhelmingly high exposure. Now, which are these families? Say, computer and mathematical occupations have 95% of roles that have more than 50% exposure. Education, instruction, and library occupations, 90% of the roles have more than 50% exposure. Management occupations, 86% have greater than 50% exposure. Business and financial operations, again, 82% have more than 50% exposure. These domains are dominated by writing, analysis, planning, documentation, reasoning. Exactly the kind of tasks LLMs can transform. Okay, but what are the least exposed sectors? Well, these are the occupations built on physical interaction, machinery or in-person labor. So, if you look at job families like construction and extraction, 95% of the roles have less than 25% exposure. Similar for production and occupations, farming, fishing, and forestry. Here, AI simply cannot assist with real-world movement, special manipulation, and manual equipment operation, at least for now. All right, fine, but what does this mean for your job? Well, see, exposure isn't about job titles, seniority, or prestige. It is about task composition. A junior analyst may have more exposure than a senior manager. A data scientist may be more exposed than a doctor. A training coordinator may be more exposed than a construction supervisor. A simple rule of thumb is if your job is built around language, reasoning, writing, documentation, or analysis, AI will meaningfully change how you work. But if your job is built around physical tasks, machinery, special judgment, or in person care, your exposure remains low, at least for now. You can check your own exposure level by drilling down through the pivot table linked in the description. I have shared the full data set, the code that I used for GPT calls, the recreated exposure sheet, which wasn't shared by original researchers, and also visualizations in the description. Feel free to explore them and share your own insights. You can look out for your own job title and description in the list and see how exposed your particular job to AI is. All you have to do is go to the pivot table in the sheet and expand and look for your own job title or role description. In case you are unable to find your particular job role, you can also look for alternate job titles and see which job role your title corresponds to in ONET database. So guys, that is it for this one. I have tried my best to assess the impact of AI on various jobs through a data-based approach and not just mere guessing. So as you know, a lot of effort has gone into making this video. And so if you found this helpful, please like, share and subscribe. It genuinely helps in supporting the channel. In my next video, I'll build a macro dashboard to track economic cycles and walk you through how I'm going to use it to build my own portfolio. Thanks for watching, and I'll see you in the next one.